Welcome to this video. It's on the fundamental counting principle, and if you have found your way towards this video, you are probably working with probability, or you're going to be working with probability soon. So the fundamental counting principle. I created a quick definition there. I don't know if you'll find this definition in any book anywhere, but this is kind of what I thought the fundamental counting principle was, and so maybe it'll help you understand it. And maybe it's not even a definition, maybe it's just what it's used to do. So the fundamental counting principle is used to determine the number of outcomes possible for numerous events occurring. And if you look down here, how do you calculate it? This X is a multiplication sign. So you just take the number of times the first event occurs and you multiply it by the number of times the second event occurs, and that'll give you the possible outcomes for, if you have two events. Now, if you go to add more events, like say a third event or a fourth event or a fifth event, you just keep multiplying the number. You keep multiplying the number of times that those events occur. So, I mean, this can be used for two events. It can be used for 3, 4. It can be used for however many events that are actually being used. And so let's go ahead and get into some of these problems. And just remember, these are questions that if you feel comfortable answering without listening to my explanation, then you go ahead and pause the video and work those out to make sure that you've gotten the correct answer. And then if you maybe aren't comfortable with that, then you just listen to a few of these examples, and then the last few examples you pause the video on your own and check to make sure that you've got a good understanding for this. So okay, this question here says the English alphabet consists of 26 letters. What are the possible number of 3-letter arrangements that could be created? Fundamental counting principle. We don't want to start writing down all possible 3-letter arrangements, because if we start writing those down, we're going to be here for a long time. So fundamental counting principle, what is it going to do? Well, it says how many letters are we using? 3 letters. So when you do this, I would like you to put 3 spaces there to let you know that you're supposed to have 3 spaces filled up. Now, how many letters could be used for the first letter? 26 different letters. So, I mean, even though I put A, B, C, we could have A, X, Z. You could still use A twice. Now, for the second, you can still put 26 letters there, because it never said anything that you were not allowed to repeat. So if you're allowed to repeat, then you can have all 26 letters. In that case, we could have A, A, A. That would be one of those 3-letter arrangements. And the third one is also 26. And so what you're supposed to do now is you're supposed to multiply those 3 numbers together to get the total possible 3-letter arrangements that are possible. So you go ahead and do that, and then check it with mine. I believe if we are looking at this, when you multiply those out, you should get 17,576 different ways to arrange 3 letters. So that is the number of 3-letter arrangements that you will have. Remember, if you have 26 times 26 times 26, that's also 26 cubed. That might save you some button pushing in your calculator. All right, let's look at this next one. It's still very similar, but you have to pay attention. There's some minor details that have been changed here. It says the English alphabet consists of 26 letters. What are the possible number of 3-letter arrangements that could be created if letters cannot be repeated? If they cannot be repeated. So how many different letters are we arranging here? 3 of them. So we're rearranging 3 of them. So once again, put your 3 spaces. And it says we're supposed to multiply between all 3 of those. So in the first slot, how many different letters can go in the first slot? 26. Now, if you cannot repeat, how many can go in the second slot? Well, if you've used the 1 letter already in the first slot, the second slot can use all the letters but the one that was used in the first slot. And in the third slot here, you cannot use the letters from the first 2 spots. And so that's what we have. So when you go ahead and multiply those out, see what you get when you multiply those out. And this is going to be 15,600 different ways. 15,600 different ways. All right. Look at the next situation here. It says telephone numbers in the United States consist of a 3-digit area code followed by a 7-digit local telephone number. If the first 2 digits in a telephone number cannot begin with a 1 or a 2, how many different numbers are possible within each area code? So if you look there, well, let's go ahead and see what the situation is. The situation says that we're going to have a 3-digit area code, 1, 2, 3, followed by a 7-digit phone number, 1, 2, 3, and we all know there's a hyphen there. So there's your 7 digits. Let's read through. It says if the first 2 digits in a telephone number cannot begin with a 1 or 2, cannot begin with a 1 or a 2. Now, when it says the first 2 digits in a telephone number, now what's the telephone number? Well, if we look, this is the area code. This is the area code. And this is the telephone number. All right, so there we go. So we know in those first 2 spots, those first 2 spots cannot be a 1 or 2. Both of them. You cannot have a 1 or 2 in either one of them. All right, so now that we got that figured out, now let's go ahead and answer the question. The question says, how many different numbers are possible within each area code? How many numbers are possible within each area code? Well, if we look here, we don't need to worry about the area code and how many different area codes there are. We're just trying to figure out how many different phone numbers in that area code you can have. That's kind of helpful because if you're like the telephone company, you're assigning phone numbers, you want to make sure that you have enough telephone numbers to pass out to the different people that live in the area. So if you're living in a larger city, you may need more than 1 area code. All right, so let's go ahead and figure this out. Since we don't have to worry about the area code, we're not going to deal with any of those numbers. So within each area code. So since the first 2 spots, you cannot have a 1 or a 2. Well, what numbers are possible to put into a telephone number? What numbers are possible to put into a telephone number? Well, basically any number from 0 to 9, right? So how many numbers are from 0 to 9? There are 10 of them. Okay, so if there are 10 numbers from 0 to 9, in the first two spots you cannot have a 1 or a 2, so how many numbers are there? 10 minus 2 is 8. There's 8 numbers left. So in the second spot you cannot have a 1 or a 2, so there are 8 numbers there. I'm going to erase that hyphen, that way it doesn't look like a minus sign. In the third spot, you can have any number from 0 to 9 there, so that's a 10. And that's the same with these last digits here. They are all 10s because you're allowed to have any number from 0 to 9 there. So basically, we have to multiply. You might be grabbing a hold of your calculator, but you really don't have to. Let's look at these two numbers here. We know 8 times 8 works down in the lower left. 8 times 8 is 64. Multiplied by, well, 10 times 10 times 10 times 10 times 10, that's going to be a 1 with, there are 5 tens there, so 5 zeros. So now we have 64 times 10,000. 64 times 10,000 should be easy enough to multiply. $640,000. 640,000 is your answer there. So that means that you have 640,000 different phone numbers that you can put in one area code. So therefore, like I said before, if you're living in a larger city, the city, you know, might have only one area code that'll fit 640,000 people, or it might need 2 or 3, depending on how large the city is. Let's move on. And this says, this question says, talks about a die, which is like a dice that you play, that you use for games. How many outcomes are possible when rolling a 6-sided die 5 times? Many people want to just do 6 times 5, and that's not the correct answer, because how many times are you actually rolling this number cube, this die? You're rolling it 5 times, so you put 5 marks there. So you have those 5 marks there, and you're rolling this 6-sided die 5 times. So on the first roll, 6 different numbers can appear. On the second roll, 6 different numbers can appear. And the reason why this is because when you roll a number, it doesn't come off of the die. It still stays on there. And so that's what we have. 6 times 6 times 6 times 6 times 6. And if you want to type it into your calculator quickly, we know that that is 6 to the 5th power. And 6 to the 5th power is 7,776. So there's 7,776 different outcomes when rolling a number cube, a 6-sided number cube, 5 times. This next situation, wow, let me slow down here. This next situation asks the same question except with a except with a 6-sided die, we're using a 10-sided die. And how many times are we going to be rolling that? 5 times. 1, 2, 3, 4, 5 spaces. In those 5 spaces, how many times can you, or how many different numbers can you get on a 10-sided die? You can get 10. in the first one. Get 10 in the second, third, fourth, and fifth one. So therefore this is 10 to the fifth power, which we know is a 10 with 5 zeros. So the answer, 100,000. The answer is 100,000. And let's move on. Actually, I want to move back. Just a quick heads up. This is back on this example here. 10 times 10 times 10 times 10 times 10 is not 10,000. It is 100,000. I messed up there. I will try and get that fixed. Actually, I will get it fixed. I just don't know when I'll get it fixed because of, but I want to get this up and running on the web. So please note that I do make some mistakes. So if you notice any others, just let me know. This one is 64 times 100,000, which is going to be 64 with 5 zeros, 6,400,000 different ways. I thought that first number looked a little small, so 640,000 was a little bit small, so 6,400,000 different ways. Sorry about that. Let's move on. This is how many outcomes are possible when rolling a 10-sided die twice and a 6-sided die twice. So you roll the 10-sided die twice, you roll the 6-sided die twice. So how many different outcomes are possible? Well, in the first slot, you're rolling the 10-sided die, so 10 outcomes possible. Second slot, 10-sided die, 10 outcomes are possible. Third slot, 6-sided die, so you can get 6 different outcomes, and that's the same way with the fourth one, 6 different outcomes. So let's try this again in our head and see if we can get this one right. 6 times 6 is going to be 36, and 10 times 10 is 100. And when we take 100 times 36, we get 3,600. So with this situation, rolling 10-sided die twice and a 6-sided die twice, 3,600 different possible outcomes. We're talking about a deck of cards. A deck of cards has 52 cards in it, so we're going to be using a standard 52 card deck. How many different hands are possible when 2 cards are being dealt? Well, if we think about it, you're getting 2 cards. If there are 52 cards and you are dealt first one, there are 52 choices that you could possibly get. You could possibly get 52 different cards. You're only going to get 1 card, but you have 52 different choices that could appear in your hand. Now, you're not putting it back because you're getting 2 cards. So you're not putting the first one back, so that means the first one's already in your hand. So there's 52 cards possible for the first slot, and if the first one's already in your hand, then you only have 51 choices for the second slot. So when you take and you multiply 52 times 51, you're going to get 2,652. There are 2,652 different ways to get a two-card hand when playing cards. And some card games actually will give you 5 cards. So what's a total number of different hands that you could possibly get when playing with a 5-card hand. 1, 2, 3, 4, 5 cards. 5 cards. So if we think about this then, 5 cards, first card, 52 cards are possible. The second card here, if you have 1 card in your hand, there are 51 cards that you could possibly get. And if you have 2 cards in your hand, there are 50 cards you could possibly get. And if you have 3 cards already in your hand, 49 cards. And if you have 4 cards in your hand, 48 cards you could possibly get. And so your question might be, well, if I have 1 card, the other people I'm playing with also has a card. Well, that's true, but you don't necessarily know what their cards are. So that's why, according to you, there's only 51 cards, 51 different cards that you could possibly have, because you already know what one of them is. So you don't know the other player's hands. So how many different hands could you possibly get? Well, when you take and multiply these numbers out, $311,875,200 different 5-card hands that you could get when playing cards. And let's look at a manufacturing situation here. Manufacturing is a company that that makes things, that produces a product that they can sell, whether it be cars or furniture, airplanes. It could be, as far as just pens, pencils, paper clips. It could be stuff to containers, bowls, cups, glasses, just various different products that could be manufactured. So if we look here, this manufacturing company uses an 8-digit serial number for their products. The serial number consists of 3 letters followed by 4 numbers. The serial number always begins with a vowel. How many serial numbers can be issued? Okay, well, there's a lot of information here. First piece of information, 8-digit serial number. So let's go ahead and put 8 digits. 1, 2, 3, 4, 5, 6, 7, and 8. Next off, the serial number consists of 3 letters. So these 3 are going to be letters followed by 4 numbers. If it's 3 letters followed by 4 numbers, that can only be 7. It can only be 7. So let's go ahead and change that then to 7. Change this to 7. It uses a 7-digit serial number. Okay, there we go. 7-digit serial number. First 3 are letters, followed by 4 numbers. So these, this also gives us some stipulations here. The serial number always begins with a vowel. What are your vowels? Your vowels are going to be A, E, I, O, and U. The serial number always begins with a vowel. So that means the first number has to be a vowel. So how many options do you have for the first number? You have 5 options. For the second option, it just has to be a letter. It can be any letter. There's no stipulation on which letter it is. So there are 26 letters, and that's the same for the third number, 26 letters. Numbers, there's no stipulation on which numbers you can use, so we're going to use the numbers 0 through 9 because that's a one-digit number. How many one-digit numbers are between 0 and 9? 10. And that's the case for all of these because all 4 of these are going to be numbers. And so when you take your calculator and you multiply these, you should get a number that looks something like 3,300,000. Yep. Try this again. I forgot 1 0 there, I believe. Yep, there we go. That would be 33,800,000 different numbers that they could be issuing. So that means if they manufacture a product, they can manufacture 33,800,000 different of the same thing, the same product, and still issue a different serial number for each item. That's with 7-digit serial number, following the stipulations that the first one's a vowel, the first letter is a vowel. And let's look at one more here. This says this manufacturing company uses an, I forgot to delete the N, uses a 5-digit serial number for their products. The serial number consists of 3 numbers followed by 2 letters. The serial number always begins with an odd number. How many serial numbers can be issued? So we know that it's 5 digits. 1, 2, 3, 4, 5. The first 3 are numbers. And the last 2 are letters. We know the serial number always begins with an odd number. Well, if we're looking at numbers 0 through 9 for single-digit numbers, your odd numbers are there. So how many odd numbers are there? First one has to be odd. There are 5 odd numbers. Now the next 2, they can be whatever. They can be 0 through 9 as long as they're a number. So 0 through 9 is going to be 10 choices for the next 2 spots. And the last 2 spots, they just have to be letters. 26 total letters that you could possibly choose from for the last 2 spots. So when we multiply these out, $338,000 different serial numbers that they could have in their system to identify the products that they are manufacturing and shipping out to be used. 338,000. That's a quick lesson on the counting principle. Make sure that if you have any questions, you let me know.